Hello everyone. In this lecture series, I'll cover the basics of radio frequencies. What is radio frequency? Radio frequency is any of electromagnetic wave frequency that lies in the range starting from around 3 kHz to 300 GHz. This 3 kHz to 300 GHz is ranging from the intermediate frequency to the high frequency ranges. What is the purpose of using the radio frequency? The radio frequency is used for various types of wireless broadcasting and communication. We use transmitter, receiver and antennas to transmit, send, receive and to communicate. What are the applications where we use the radio frequency? The radio frequency is used in various wireless devices such as cell phones, radio, TV, broadcast, Wi-Fi and Bluetooth. We can say that for higher frequency, we can say that satellite communication is an example for the high frequency applications. This picture shows the RF system in a simple way. Let us consider this is a two system in which this is a device 1 and device 2, and they are trying to communicate each other and talk each other. So this communicating is done by the waves. So here this is a device 1 which is trying to communicate to device 2, that we call as transmitter data, and here and the device 2 is communicating with this send the data, we call as a receiving the data. So this electromagnetic field waves will have the data in it. So as we can see, this system electromagnetic waves will carry the radio frequencies. So we have to consider the two cases in this. So for example, if the device 1 is going to transmit the data, so this will act as a transmitter, and then device 2 will act as a receiver, which it will receive the data. And there is a second case where this will act as a transceiver, like this device 1 will send and receive the data, and this device 2 is also send and receive the data. So while designing this RF system, we have to be very careful, because first thing is we are going to deal with the radio frequency RF signal, and second thing is we can say this system is not physically connected. So this we can say as an wireless devices. The radio frequency is divided into several ranges or bands. With the exception of lowest frequencies, each band represents an increase of frequencies corresponding to the order of magnitude. There is a following band which depicts the RF spectrum frequency, which is ranging from the low frequency to the extremely high frequency. This frequency table I'll show in the next slide. As you can see, this is the RF spectrum table. Here you can see the frequency has been divided into number of ranges, and here is of very low frequency ranges, that is 3 kHz to 30 kHz. To the medium frequency ranges, here you can see 300 kHz to 3 MHz. To the super high frequency, here you can see 3 GHz to 30 GHz, and extremely high frequency is of ranging of 30 kHz to 30 GHz to 300 GHz. So here you can let us see what about the wavelength. We can see first. So wavelength is nothing but the speed of light to the frequency of oscillation. That is that lambda is directly proportional to the frequency of 1 by f. And here you can see that when the frequency is low, your wavelength is high. When the frequency is high, the wavelength is low. That is, when the frequency increases, that wavelength will get reduces. That's why we say this. When the high frequency ranges, here you can see the wavelength is of 10 mm to 1 mm. So this we called as a millimeter range application. So this I'll show in the next slide. What is the wavelength? Here you can consider. Let us see, this is the wave. Imagine that. So when we talk on the water, we'll produce the wave. Here you can see this is the cross section of the wave. Wave is nothing but the distance between these two peaks. Here I'll show you that the distance between these peaks, that is nothing but this distance we called as a lambda. distance between this wave. And here I'll show the difference between of this wavelength. And here this, let us consider this wave we called as an F1, and this is this wave we say as an F2. So this F1 frequency is high, that is nothing but when the frequency is high we produce this shorter length, that is F1 is greater than an F2, whereas that lambda of 1 is less than lambda 2. So here you can see this is nothing but we called as this lambda wavelength distance is less, that is the shorter wavelength, and here this wavelength is large, that's why we called as a longer wavelength. So application of this radio frequency I'll show in the next slide. Here you can see the frequency versus application, which is ranging from low frequency to extremely high frequency range, which is ranging from 3 kHz to 300 GHz. And here you can see that the intermediate frequency range is whatever you are using the day-to-day lab applications like TV, cell phone, broadcasting, all will falls in the intermediate of 300 to 3 GHz. And here you can see the satellite communication where it is ranging from 30 GHz, and for the radio astronomy we use the 300 GHz. So we'll see the next slide. What is the purpose of using the high frequencies? Why do we operate at high frequencies? The frequency spectrum is quite fragmented and dense. This encompasses one of the reasons that we are constantly pushing the applications into higher and higher frequencies. Here, some other reasons are efficiency in propagation, immunity to some form of noise and impairments, and the size of the antenna is required. The size of the antenna is related to the signal wavelength. That in practice we usually say that 1/4 of wavelength. And here in next lecture series we'll discuss about the noise, RF noise. Thank you.